In this video, we're going to talk about the fire alarm basics, and we're going to first discuss the relevant code sections in the New York City Building Code that pertains to the fire alarm systems. And if you are outside of New York City, if your project is outside of New York City, you would have to follow the local codes for your project, and it's going to be probably very similar to the New York City building codes that deal with the fire alarm systems. And the NFPA code that relates to fire alarm systems, so we'll kind of discuss what those NFPA codes are. Then we will discuss differences of a conventional and addressable type fire alarm systems. Then we'll discuss the various components such as the fire alarm panel, notification devices, and initiating devices. So we'll kind of go over these basic ideas in the fire alarm system. So, when you start a job, you have to first look at the relevant codes that deal with the fire alarm to see whether it's required for that location. So in New York City, that section is actually Chapter 9, Section 907. So if you go here, and if you go to the New York City Building Code, so under here, the latest one is 2022, and then you go to Building Code, you'll see Chapter 9 deals with fire protection systems. So the first part of this code section deals with sprinklers, and then the second part, so basically here it deals with mainly sprinkler stuff, and then if you go down towards somewhere in the middle, it's going to start to talk about the fire alarm system requirements. So here you could kind of read through this to get the requirements in New York City. I'm just going to go over kind of like the main structure of this section. So they basically state the occupancy type. So Group A occupancy will have these requirements. And if it falls under any of these criteria, then you would need a fire alarm system. And then it goes on to explaining under what conditions you would need a fire alarm system in Group B, and also for other various type of occupancy groups here. So once you have a project and you have the type of building usage, whether it's going to be for a restaurant, the number of occupants for that building area, you would have to first go into this section here, which is Chapter 3. And Chapter 3 is use and occupancy classification. So under here, you could find the corresponding occupancy group based on your project. So in this example, I'm just going to kind of say it's for a assembly group A. It's a group A occupancy. And under this, let's say it's a restaurant. So a restaurant falls under the A2 assembly group. And the assembly group is basically group A. So if we needed to know whether the fire alarm system was required for that restaurant, we would then go back to this Chapter 9. So then we would have to see what are the requirements for the Group A occupancy. So that would be this section right here. And if you read this, it basically states that if the assembly occupancy is 300 or more people, and there's some other exceptions here that you would have to kind of read through, depending on whether it's used as a cabaret, or if there is some sort of stage, there's some different requirements for it. But for a restaurant, it would just fall under this, and if there's 300 or more people, you would be required to put a fire alarm system. So that would be the first step of determining whether or not you would even need to install a fire alarm system for the building. There are some cases where people want to just install a fire alarm system, even though the code does not require it for maybe some sort of insurance requirements. Maybe if they have a fire alarm system, they can get a reduced insurance rate. So sometimes, there might be other reasons why a fire alarm system is installed. So basically, based on the occupancy type and other criteria that's listed in the code, you basically determine if the fire alarm system should be required. So we just discussed that. And the occupancy type can be determined in Chapter 3 of the New York City Building Code, and we also discussed that. Design of the fire alarm system should be based on both the New York City Building Code as well as NFP 72. So this is the National Fire Protection Association. The code is 72, and this one deals with fire alarm systems. So New York City Building Code or the local codes of your project would first determine whether or not a fire alarm system is required. And then they would have their own requirements within the code, within the local code of the project. And also, you would have to combine it with the requirements of NFP 72 to create the entire fire alarm system. So it's a combination of those two codes that should be used mainly to design the fire alarm system. There might be other codes, but those are the two main codes that should be followed when designing the fire alarm system. So in a fire alarm system, you have initiating devices as well as notification devices. So I'm going to talk about the initiating devices first. The first one is smoke detectors, and they look like this, and they're typically on the ceiling. Then you have elevator smoke detectors, which are basically smoke detectors that function in a way so that if it is actually activated by smoke, it initiates elevator recall. So elevator recall is if there is smoke detected by one of these elevator smoke detectors that are generally located in elevator lobbies, so basically in front of elevators, as well as in elevator machine rooms. Once it is activated, it initiates an elevator recall sequence, which basically will take the elevator, bring it straight down, and it overrides any other function. So if someone's trying to go to the 5th floor, it'll just take it straight down to the 1st floor, open up, and basically stay open, and nobody can use the elevator except for the fire alarm department. If they come in, they can actually override that system. If there is smoke on the 1st floor, which is the level of discharge, then it'll go to a 2nd floor, or basically an alternative floor, which is probably going to be the 2nd floor, and it'll basically open up there and stay open, and the elevator will not be able to be used by anybody else in the building. Then you have a duct smoke detector. So basically they look like this, and it's basically mounted in the duct. So in a HVAC duct system, this nozzle right here with the holes will basically be inside the portion of the duct. And then this portion right here would be sitting outside of the duct, like in this picture right here. So this is the container, and the smoke detector, this smoke detector is actually mounted inside of this kind of plastic container. So as the smoke is passing through the duct system, it'll go into these nozzles, and then it would end up into this container, which would then set off the smoke detector. So this is what a duct smoke detector looks like. Heat detectors look like smoke detectors, but it basically senses heat rather than smoke. Then you have manual pull stations, which look like this. You've probably seen these in buildings. Basically, if there's a fire, this allows any occupant in the building to basically pull this down, sending a signal to the fire department, basically. So this would activate the fire alarm system, and the fire alarm system would basically automatically call the fire department. You also have CO detectors, which are carbon monoxide detectors, and those also look similar to smoke detectors and heat detectors. You have water flow switches, which look like this, and this is the portion that sits in the pipe, and this portion is sitting outside the pipe. So it looks like this once it is installed. The portion here is inside the pipe, and whenever water flows through, it'll activate the switch, and then that will activate the fire alarm system. And these are on sprinkler systems, just to basically notify to people that the sprinkler system was activated. Then you have tamper switches, and they look like this. And once installed, it looks like this. So basically, this part would go through here, and then in the handle itself, there would be a groove that is cut where this would basically sit inside. And as it is turning, this stem goes up or down. So if the stem is up, it means the valve is open. And when the stem is down, it means the valve is closed. So as somebody's trying to close the valve, it would trip this tamper switch and activate the fire alarm system. It is basically to notify people that the sprinkler valve has been closed, which could be an issue in a fire condition. These circuits of these devices are referred to as SLC, which stands for signal line circuits. And on addressable systems, that's what it is called. On conventional systems, it's called IDC, initiating device circuit. And I will basically discuss conventional and addressable type systems later on in this video. So then we have notification devices, and notification devices basically notify the public that something has happened. And the initiating devices are devices that initiate the fire alarm system. So some notification devices are strobes, and strobes look like this. And basically this part just flashes a light if there is some sort of alarm condition, such as if a smoke detector goes off or a water flow switch goes off. It would basically activate the fire alarm system and the strobes would start to flash. You also have horns as a notification device. Horn strobes, which are a combination of strobes and horns. All right, and they look something like this. So you can see this portion here is the horn portion, and this is the strobe portion. So this would be a horn strobe. You can also have speakers. So this can actually be a speaker rather than just a horn that would activate a beep. So it's like a beeping tone. If you have speakers, it would activate a voice alarm, which will be pre-recorded, or sometimes it can be a live voice message. You can have speaker strobes similar to this. And you can have a ceiling mounted type speaker strobe or a horn strobe that will basically look something like this. So in this diagram, it just represents a very basic fire alarm system. So this is the fire alarm control panel. It's also called fire alarm control unit, and it gives different type of signals, right? It could give an alarm, a trouble, a supervisory. Trouble condition are things like an open or a ground in the wiring, which could affect the fire alarm system from actually operating correctly. So that would be a trouble condition. You can also have an alarm condition, which is when a smoke detector, heat detector, water flow, these things go off. You can also have a supervisory, and a supervisory includes things such as the tamper switch. So if a tamper switch is activated, it would actually be a supervisory signal. So in this case, the initiating device is connected to the fire alarm panel. And you could see here, if it's a conventional type system, it's called a IDC, like I mentioned before, initiating device circuit. And if it is a addressable type system, it's called a SLC, or a signaling line circuit, or a signal line circuit. Then you have a different circuit, which would be your notification devices. So it will be a separate circuit from your initiating devices. And the notification are the devices that I just mentioned, such as speaker strobes, speakers or just strobes. And they show some other systems here. So you have the primary power, which is going to be 120 volts. In New York City and other places, it might be a different voltage. But in the US, it's a 120 volt single phase typically. Then you have a secondary power in case your primary power goes off. There is a battery backup system that would operate your fire alarm control unit for a certain amount of time. Then in this panel, you have a communication to supervising station. And the supervising station, in other words, would be a central station. And a central station is basically a 24-hour, 7 days a week operational location that once they receive a signal from the fire alarm panel, it would basically send the alarm signal to the fire department automatically, and the fire department would be able to come to the building location very quickly.